review this weekend.
Okay.
Yeah.
So do you have some problems to review?
Yeah, for review, let's do it. Okay, these are new, and
Okay.
they're a little interesting.
Yeah.
But it's like asking you to work backwards from.
Yeah.
Okay, so in parentheses, it says 2xy minus blank.
Oops, excuse me. Difference of squares, right?
Yes. And then another parentheses, blank. Yeah.
You must have the same teacher. You must be in the same class as the other student I just had.
Oh, really?
Uh-huh. And this says blank blank 5z squared? No.
5z to the power of 4, yeah.
5z to the power of 4. Yep. I have seen this problem. This is the first time I have seen problems of this type in 5 years. You want to know why?
Huh.
Because this is their way of defeating the Inspire CX. In other words, the Inspire can do just about anything. It can factor anything for you. And it can expand anything. And it can complete the square. But it can't answer problems like this. You have to know what the difference of squares is to know how to do this problem.
Lovely. Lovely, lovely.
Well, it's a good thing. I'm glad, because once I started looking at my Inspire CX and realized what it could do, I wondered what the implications were for math. I mean, what are you going to teach kids if you don't teach them factoring? Okay? So this is the difference of squares. So in our case here, it's already been factored to that. So what is A, what is B, and what is the sign of this term?
Okay, so that term would have to be positive, right?
Yep.
Okay. Okay. And
What's A?
A would have to be 2xy.
2xy. No.
Okay.
In other words, they've given it to us in factored form like this. So we're looking at A and we're looking at B. 5z to the 4th. So they didn't ask us to come up with a squared minus b squared, right? They just wanted you to fill in the blanks. Well, if you're doing difference of squares, it has to be a minus b times a plus b. So they gave us a, and they gave us b, and they gave us this sign. Everything else we could figure out.
All right.
Okay. There's 2 of those, right?
Yep.
Hold on a second. Just realized something. I have this. And it's in my, this is you're taking honors algebra?
Yep.
Is that right?
Mr. Moore's honors too. Yep, that's it.
Okay. Let me get this. Let's see. What are we?
Number B, or letter B.
We can look at some of the others also. It doesn't like me having these windows open. Can you hear me okay now?
Yeah.
Sarah, can you hear me? Okay. So the second one here, B. These are actually very easy once you get the hang of it.
Okay, so then
Difference of squares. So they gave us A and they gave us B. What is A and what is B?
So A would be 14h squared. Yeah, negative 9 squared.
Huh? Yeah. My opening this document seems to be impeding our audio. Let me close it, at least for the moment. Does that help?
Yeah.
My audio?
A little bit.
Yeah, it helps me a lot. You were really choppy there. So, in other words, they gave it to us as, this was the plus 9, and this was 14h squared, and we have to fill in the blanks, right?
Mm-hmm.
Now we know that a squared minus b squared has AA, so this has to be 14h squared. Signs have to be different, so this has to be minus, and this has to be b. So there you go. There's a plus b times a minus b. Okay. Yeah, I finished my session this morning, and I thought a lot about these problems as to why I had never seen them before. And it finally occurred to me that this outsmarts the TI.
They have to make
you
us
can't solve. Well, you can't solve these on the TI. They gave you more normal factoring problems, like I've been dealing with for the last 5 years, where they just give you a polynomial and they say factor it. That no longer is a problem, because people are going to stick it into their calculator and not know how to do it. They'll just give out the answer. But doing it this way forces you to know what you're doing. So you're doing difference and sum of cubes also, correct?
Yeah.
Should we do a couple of those?
Yeah. Sorry, the audio is weird. I can hear myself being strange.
Okay, let's go with one. Do you have everything closed on your computer? Let me close one more thing here. Maybe it'll help on my end. I got everything closed that I can have closed. Okay, let's see if this works. So what does this factor into?
That factors into, okay, so A, isn't it A times?
Same sign.
Yeah.
In other words, it starts out factoring very much like difference of squares. But this term has to be a quadratic, and then the middle term has the opposite sign of this. So it's got to be that, and it's not 2AB, it's just 80. Okay? And different sum of cubes, very similar. First term, give it the same sign. Second term, give it the opposite sign. Okay?
Okay.
So in the problems they gave it to you in factored form. So read some of the ones they gave you.
They gave us, right? With the blanks?
Yeah, give me all the blanks. I guess I could pull up that document. Let me pull up the document, write it in, and then I'll close it out. So there won't be any audio while I'm doing this.
Okay.
Is that correct?
Yep.
Okay. Let me make this document so I can act. And, okay, so which are we looking at? Difference or sum of cubes here?
This would be sum, right?
Yeah, it's this one right here, right?
Yeah, you have the opposite sign in the middle term.
Okay, so what's A?
So A would have to be, well, you just move it over, right? So
A squared is 9y squared. So
yeah,
what's
so it has to be 9y?
3y.
3y, because you squared the 9, yeah.
Yes, you got to take the square root of the 9 and the square root of the a squared. Okay, and AB is equal to 12xy. So what is B equal to?
B is equal to 4y. 4x.
Okay.
4x. Right?
Yeah, 4x. No, you're right. 4x.
Have to get the x.
Exactly. So now we're ready to do it. What's this? What sign is it? And what's this?
So that's 3y. Plus 4x.
And what's this over here?
That is 4x squared. Or 16x squared.
And you see how that defeats the calculator?
Yep.
No way you could do these on the calculator. And I'm convinced that's why they've come up with them. Okay, can you read this in there? Left paren, right paren.
Huh? Sorry, the audio's
The
being
second one in this row.
Sorry, the audio's being weird.
Yeah.
Oh, yeah.
Got to put up. Is that right?
Yep.
Sarah?
Yep.
Okay.
Yeah.
Difference of cubes or sum of cubes? So it's difference of
This would
cubes.
be difference of cubes.
Okay.
Yeah.
What is B?
Mhm.
In fact, what is A?
Is A 4x squared negative 4 squared? The second one's backwards.
A squared is what? What is A squared equal to?
49.
So what is A?
7. Yeah.
So I put 7 there and make 7 there. What is B?
28 x squared.
Remember that it's A minus B. So they've already written 4x squared in there, so B's got to be 4x squared. You see why?
Yeah.
Okay. So now that we know A and B, what's this middle term?
28x squared.
And the last term?
16x to the power of 4.
Very good. All right. What do you want to cover next on the thing? Because they got a lot of interesting problems on here.
The vertical motion,
Okay.
I think.
That's on a different thing, but I think I have it. The vertical projectile motion?
Yeah. The story stitch.
Incidentally, this one is not factorable that I'm looking at right here, x to the 4th plus 16. And the answer she gave you is not correct. I think it's a typo. She meant x to the 4th minus 16, which would be factorable. But the sum of squares is not factorable, and the sum of cortex is not factorable. It's certainly not equal to that.
Okay.
Okay? Just to let you know. Let's see. Let me pull up. The projectile motion, is that the one you want?
It's the one that says story scenarios. It has pictures of ducks on the bottom.
Don't think I have that one. Can you verbalize it?
Yeah. Okay, so here. Yeah. Okay, well, there's two I want to work on, so I'll start with the first one. The length of three sides of a right triangle are consecutive multiples of 7. Determine the area and perimeter of the triangle.
So, it's like 7, 14, 21 could be a possible answer.
Yeah.
They must have given you some other information.
Nope. That's the whole problem.
The sides of the triangle are multiples of 7, or it could be 14, 21, 28. Okay, I get it now.
Yeah.
So it's really 7x, 14x, and 21x. And we have to figure out what x is. What do we know? We know 7x quantity squared plus 14x squared equals 20 squared.
Yeah.
And x is any number. We know the hypotenuse has to be the last number. So I've got what I'm concerned about is I don't see a solution here. Hold on. So this is 49x squared. What's 14 squared? That's 216? No. 116.
Yeah.
No. 196. Equals, what's 21 squared?
Okay, I'm trying to pull up my calculator. Let's try it. 441.
You see the problem?
Yeah. You could...
I get no solution.
I'll mark it down to ask him about it on...
Hold on, read it again. One last time. I must be missing something.
Okay. The lengths of three sides of a right triangle are consecutive multiples of 7. Determine the area and the perimeter of the triangle.
Consecutive multiples of 7.
So, like, the first one, could you do that the first one is x?
Yeah, I don't think this is where I got it wrong. It's not 7x, 14x. Let's go back.
And then could it be x plus 7 and then x plus 14?
Yeah.
For the side?
Yes, that's the way to do it. So this has to be x plus 7, whatever x is, although x has to be a multiple of 7. other words, x can't do. X could be 0, it could be 7, it could be 14. And this isn't right either, because if x was, say x was 14, well then this one wouldn't be x plus 7. This is a 2 multiple. This one would have to be 21. And this one would have to be 3 multiples of 14. This one would have to be 42. So it's not x plus 7 or x plus 14. It's x2. Wow.
Yeah.
What's the next multiple of that? It would be 14x. And that's what we did last time. That doesn't work. And 21x. It gets us nowhere. Do you have an answer on this one?
No. We didn't get that far in class, so it's just like... Yeah.
Because it's hard for me to believe that this triangle exists, where you could have a right triangle where there would be multiples of 7 consecutively. In other words, 7, 14, and 21 are consecutive multiples of 7. That's 1 times 7, 2 times 7, 3 times 7, if that's what she means. But that's not a right triangle. And if I put an x in there so that that first side could be some multiple other than 7, in other words, maybe the first side is 21, that's 3 times 7, this would have to be 4 times 7, and this would have to be 5 times 7, 35. So that's a possible solution there. 21, 28, and 35. But all of these could be expressed as that's 7x when x is 1. Excuse me, that's 7x when x is 3. And this is, and when I read this, that's 7x plus, that's 8x. No, it isn't. When x is 3, that's 7x plus 7. And this one is what when x is 3? This one would be 7x plus 14. Ah, now we're getting somewhere. So this is 3 because we plus 7x plus 7 squared equals 7x plus 14 quantity squared. Yeah, this is going to have a solution. 49x squared. Can you square this quickly for me? Without foiling it? Based on a plus b squared?
Yeah, okay. So 49 squared.
49x squared, in other words, square that whole term. Plus 2 times a times b. Right?
Yeah.
In other words, this is a squared plus 2ab plus b squared. Okay, I'm using that same, extend this one for me.
Better, so.
Okay, sorry the audio is breaking up again, but it's getting better.
Yeah, I'm experiencing a similar problem. So what's this middle term? 14 times 14 again was 196.
Yeah.
Okay? Okay, now now everything isn't going to disappear. We can cross off this term and this term, and then we can combine like terms and end up with a quadratic that we can solve. So we have 49x squared. We have plus 98x minus 196x. That gives us minus 98x. And we have 49 minus 196. Gives us
negative 147.
Now we have to solve that quadratic. How nice. 49 we can factor out. Continue. Can you hear me, Sarah?
Yeah.
Sarah, can you continue to factor this?
No, I don't believe so. No, yes you can. Yes you can. Yes you can.
X squared minus 2x.
Because you put the... So x...
You want me to show you how to do this on your Inspire?
I don't have my Inspire with me. It's in my locker.
Okay.
Sorry.
Bring it home one day and I'll show you how to you can factor on your Inspire.
Okay, I'll bring it next one.
But I think it's a mistake not to learn how to do it manually. Signs have to be what? Opposite or same?
So then you take...
It's only two factors of 3.
So it would...
So you have
positive 3 and negative 1.
Put the bigger factor with the sign of the middle term.
Yeah.
So what's my solution?
Is... oh god. Okay, so would you have to plug it back into the original equation?
No, set that equal to 0 and set that equal to 0 and solve.
So positive 3, negative 1, and 0 for the 49.
We can divide both sides by 49. The 49 doesn't affect anything. One of these two terms has to be 0.
Yeah, okay.
So x is equal to 3 or x is equal to minus 1. Which of those is not a valid solution?
The negative 1.
Okay, so x is equal to 3. And this was our sides. So our sides were 21
and
28 and 35. Of course, that would be a right triangle. That's a 3, 4, 5 triangle. And notice that it's a multiple of 7 times a 3, 4, 5 triangle. In other words, this is 3x, this is 4x, and this is 5x. And any multiple of that will be a right triangle.
Right.
But in this case, we needed all 3 numbers to be multiples of 7. And that was tricky. That was really quite tricky. Setting this up like that was not obvious. What's the second one you have?
Okay. So... okay, it's a vertical motion problem.
Okay.
So it says you drop a rock from a 256. Oh wait. I'll let you finish writing.
Oh, that's for the... Go ahead.
Sorry, okay. So you drop
a rock from a 256-foot cliff.
Okay.
as a seagull flies below at an altitude of 60 feet. After how many seconds does the rock hit the seagull?
Okay. And you're given this equation?
Yes.
Okay. So what's h sub 0?
That's your initial height, so it would be 256.
Okay. So we have h, the height of this rock is going to be minus 16t squared plus velocity is 0 to begin with, so there's no middle term, plus 256. So that's going to be the equation that models the behavior of this rock as it falls. Now what are we trying to solve for? We're trying to solve for how long does it take to get to this altitude. Solve that for t and that's your answer. Once again, if you get a positive and a negative, throw out the negative. There's no such thing as negative time.
Right, so you have 60 minus 256. I get 12 and 1/4 second.
T is 12 and 1/4?
Oh, never mind. I did it weird.
No, you got to take the square root of that. In other words, t squared is equal to 194 divided by 16, so t is equal to the square root of that. What's that number?
Wait, couldn't you factor it if you...
You don't really need
If you
to.
move the negative 60 over?
The reason you don't need to factor this is because there's no t term. In other words, solving this is a simple matter of moving the 194 to the right side. Did I get that number right? Is it 194? 194 and 60? No, it's 196. Excuse me. In other words, it was 256 minus 60. That's 196, which is going to make the problem a lot easier because 16 divides into that. No, it doesn't.
It's still 12.25.
So what is t?
I wonder if there's...
You
Normally
should
it gives us a velocity, but there's no velocity this time.
Right, but when you drop a rock, you normally are not throwing it. You're dropping it with velocity. He could have said you drop a rock with an initial downward velocity of 10 feet per second, and then we would have had a velocity, and then we would have had to factor that quadratic to solve it. But as long as there's no initial... Yeah, if there's no initial velocity, it makes the problem easier to solve. So our answer is the square root of 12.125.
All right. And so, this is weird. Because normally he gives us like a vertical motion.
Well, right. That's because your normal problem is like this. You throw a rock up into the air. You can't throw a rock up into the air unless you have some initial velocity. There's no way it'll get off the ground unless you have an initial velocity. But if you're dropping a rock from a height straight down, you rarely throw it. You generally just drop it, and then there's no initial velocity. You merely have the gravity acting on it, and that's the minus 16t squared term.
All right.
So he was probably mixing it up a little bit when he gave you this problem to confuse you by having no initial velocity. Interesting that I didn't see that problem with my other student. I guess he was working, he worked on factoring, especially those unique factoring problems that they were giving you. And trinomial problems also. I noticed we had some of those. You and I didn't go over them, but
Yeah.
So what would you like to do with the last 15 minutes?
There are more initial volume terms. Oh, maybe
Okay.
some of the factoring, yeah. Factoring
Well,
would be a good idea.
whatever you want, Sarah. You're the one that is in the position to direct here.
Okay.
Okay.
I don't know how far he wanted us to go in the package. Well, alright. So it wants solving for inequalities algebraically. This might be a good idea.
Okay.
Okay. So 25x squared is the
3.
audio. Okay. Parentheses 25x squared
You know what? The sound is not.
minus
Go ahead.
2x and parentheses less than or equal to
Is less than or equal to
2
What's the other side?
parentheses 216 minus 3x.
minus 3x.
Okay. Notice that no matter how much arranging we do here, we're going to end up with quadratic. After we factor the quadratic, we're going to have something times something else is going to be less than or equal to 0. Did you and I last session work on sign charts?
A little bit, yeah.
A little bit, yeah.
We did?
Yes.
The
Sorry,
sound here
the
is
audio like lagging.
the sound's really bad. Let me call you. I have a solution for this sound problem, incidentally. As long as you have a speakerphone at your house or where you're at.
Yeah, like a phone on speaker?
Yeah.
Yeah.
That solution is for us to put it back on telephone instead of mic and speakers, and I will call you using Google Phone instead of using the mic on the audio by way of GoToMeeting. I've done that before with people, and it's actually worked pretty good. We don't need to do it today, but the next time we encounter such audio problems, let's resort to that as a solution.
All right.
Okay? But let's go through this real quick. Distribute these out.
So you'd have 75x squared minus 6x is less than or equal to...
Okay, I'm going to bring both of these numbers over there because I want everything on the left side. So plus 3x minus 216 less than or equal to 0. This turns this into a minus 3x. And can I divide 3 into all of that? Yes.
Yep.
So I got 3 times 25x squared minus x minus 72 less than or equal to 0. And factor this for me.
So you would get 5, or no, it's cubed. Yeah, 5x times another 5x. And then you multiply these two. So, oh, it's being a brat. Okay.
Clearly 5x and 5x aren't going to work.
Yeah. But I don't think 1 and 25 would work either.
This cannot work because 8 and 9 subtract a 1, but they don't after multiplying by 5. So let's try 0.5 and 1 real quick. Now 8 and 9 certainly isn't going to work, but 2 and 36, that produces 14. How about 3 and, oh, no, 3, yeah, 3 goes into that 24. 7, that's not going to work. Let's stick this into my trusty Inspire and see. I'm going to try to factor this in my calculator. I'm going to be amazed if it factors. 25 x squared minus x minus 72. Didn't factor. No, it just gave me the same answer over again. In fact, it did factor it. It's x minus 1.717 times x plus 1.617. So, in other words, we've got to use the quadratic. Why would they do that to you?
They hate us.
No, I'm serious, because we're going to have to use a line. We're doing something different here. We're doing let's take, I can't really remember whether we did these kind of problems last session or not. Have you and I done a problem like this? Let's ignore this.
Ours were more
Okay.
relatively.
Let's talk about how we have to do this in the remaining 10 minutes. First thing we do is define our critical points, which are any points that make the numerator or the denominator 0. So what would those be?
2 and negative 3.
Okay. We draw a line chart and we put this on it. We check points to the left of negative 3, like negative 4. Plug it in for x and see whether we get a positive or a negative number. When you plug in negative 4 here, you get negative.
So
Plug in negative 4 here, we get negative. When we multiply negative times a negative, it's positive. And the purpose of this line chart is that I only have to test one point to the left of my critical point, and everything to negative infinity is going to create that. Pluses. Now choose a point in between.
0.
Okay, 0 gives you negative here, positive here, that's a negative. We don't need to know the number, we just need to know the sign. Check a point to the right of 2, such as 3, and you get plus plus. So what's my solution to this? X has to be greater than or equal to minus 3 and less than or equal to 2. So that's the way I would solve an inequality involving a quadratic.
Okay.
Why they made it so hard that they made you have to use the quadratic formula to solve it, I don't know. That's silly. Because let's go back and do this one more time, and I'm going to make it harder yet. That's the way you do products. So let me change the problem. Now go through the process with me. And let's make it that. Well, let's just make it greater than.
Jesus. Okay.
What are my critical points?
Positive 5 and negative 3.
And I would advise not putting 0 on your chart because it makes it look like it's a critical point. What's the next step?
Test to the left and right of each critical point.
And in between? What happens to the left of -3?
Okay, it becomes a negative over a negative.
Okay.
So you get positives.
Okay. What happens in
And
between?
You get negatives in between because it's a negative over a positive. Yes, negatives in
If you
between.
plug in 0 for x, you get -5 over +3, so you're right. And then to the right of 5?
6, so you'd get positive and positive.
So how would you describe the answer?
X has to be greater than -3,
Less than?
or less than -3, sorry. And,
Or?
sorry, greater than positive.
It's okay, I wasn't positive myself, whether it was an and or an or. But I think it's an or. So that's how you do inequalities involving the product of functions or the ratio of functions. It's not obvious that that would be that difficult and require you to have to use a sign chart like that, but you do. You particularly have to do it when you have the ratio of linears. When you have the product of it, you could probably figure out a quick and dirty method of doing it. It's a little easier, but I just always use sign chart automatically. Whenever I have an inequality and some sort of a quadratic or something that's going to produce a product of two things or the ratio of two things.
All right.
Okay. But that was where that problem was leading. The only thing is they decided to trick it up and make it so that you couldn't factor this thing. Boy, they really did too, didn't they?
Yeah.
Oh, no, this is a different problem, isn't it? Okay, this is just a straight problem, but they really did trick it up needlessly. Unless I made a mistake in my math. 3 goes into that 72. No, I don't think I did. All right. We got about 4 minutes. You got any last quickies that we can do?
Distributes and simplifies. That
Okay.
shouldn't take too long.
All right.
Okay. 6x squared minus 5x minus parentheses 9x cubed plus 5x squared end parentheses plus 8x parentheses 7 negative 5x. 7 minus 5x.
Okay. What sign is in front of it? This is times the 8x?
Yes.
Like that?
Uh-huh.
Okay. So, like I tell everybody, when you have a subtraction, turn it into an addition. So the easiest way to get rid of these parentheses is what?
To distribute the negative.
Okay. Makes minus 9x cubed. What sign goes on the 5x squared?
A negative, right?
Uh-huh.
Because positive, yeah, okay.
Okay. Now let's distribute this.
Negative, or positive 56x minus 40x.
Minus 40x squared.
Squared.
Okay. So now we have this. So now what's our highest degree polynomial? Minus 9x cubed. And I only see one of those. So we'll put that starting. How many x squareds do we have?
We have 3.
What are they total?
Negative 41x squared.
Got 6 minus 5, which leaves 1.
Oh, so negative 39 x squared.
How many x's?
Got 2.
What are they total?
51x.
Plus 51x, because I have to put a sign in front of it, notice.
And then your negative 9.
Is there a number?
Nope, I don't believe so.
Okay. Alright, so that's your answer. Alright. I guess we will talk again on Wednesday at 3. Is it 3 or 3:30?
Sounds great.
Is it 3 or 3:30?
3:30.
3:30.
I think it's 3:30.
I think it's 3:30 also, yeah. Okay, Sarah, have a good rest of your weekend. Talk to you
Okay, you
Wednesday.
too.
Bye-bye.
Bye.